So this afternoon we are going to be going through just a quick recap of graphing a sinusoidal function, and then we're going to be learning about some of the transformations that can take place inside of these functions. We'll do a couple of examples, and then of course you're going to have your afternoon assignment to submit. So our first example is just a review of what we've done so far. I'm going to ask you to graph a sinusoidal function with the axes at 3, an amplitude of 2. It starts at the point 0,3 and it has a period of 360 degrees. So it takes 360 degrees to do one full rotation. Pause the video, try it, and then unpause it and we'll take it up. Alright, so as you can see, I have put a little bit of information in here. I've drawn in the sinusoidal axes at 3, and I drew a little line here at 5 and another one at 1, because that would be where my maximum will be, 2 up from the middle point and then 2 below from that middle point. I've drawn my first dot at 0,3, it told me that's where it starts. And then what you can see too is that I've drawn another one at 360 and another one halfway through at 180. So I know my function is going to have to reach the top, come back down to the middle, reach the bottom, and then come back up to my axes again. I can now add in a couple more points and then connect these dots. So halfway through 0 and 180, I know it's going to reach a maximum. So 2 above that middle point, come back to my middle point, and then halfway through the 180 and the 360, I know it's going to reach my minimum and then come back up. So we have another example. Again, take a look at this. Pause the video when you're ready, and then when you come back, I'll have graphed it for you. We have to graph something that has an axis at 2, an amplitude of 3, and it needs to start at the point 62 with a period of 360. All right, so I have plotted a couple of things. I've drawn in my axes. I put a point 3 lower and then 3 higher. So this is going to be the lowest it gets, and this is going to be the highest it gets. I've put my starting point in at 62, and then I put in another point at 420. So it said that I have a 360 degree period, so I know that I'm going to have to do one wave in this period. And the way that I got the 420 is I just said, okay, well, this is 60 degrees past 0. This is where I'm starting. So I had to go 60 degrees past my 360. That's how I knew that this would be 360 degrees. I have figured out halfway, so halfway between 60 and 420. I put that dot here, and then I broke that up again into half, and I know that it's going to go up, back to the middle, back to the bottom, and then back up. Alright, so we're going to be thinking about quadratics before we start looking at some transformations for sinusoidal functions. We know that this -3 that's out front tells us a couple of things. We know that the negative tells us if it's going to be reflected or not. So this is going to be a happy or a sad parabola. We know that the 3 out front tells us if it is skinny or not. Skinny or fat, I'll say. In this case, it's a 3, so it's been stretched. It's skinny. This 4 right here in the bracket tells us it's part of the vertex. So this is the shift left or right. Now remember with these ones, it's always backwards. So this one is actually, since it's a -4, that actually means that it is a shift right. There we go. And then this last +5 here, this tells us if it is a shift up or down. Since it's a +5, it means that it's been shifted up 5. Thinking about those transformations in our parabolas, we can do the exact same thing if it's a sine function. So the difference between my original sine function, so y equals sine x, and this new sine function, y equals 2 sine x, is this 2 right here. So since it's out front, This is a vertical stretch. So I'm going to make it skinnier. I'll just write skinnier here. So if I was going to sketch this, this 2 is so important. It doesn't mean that my amplitude is 1 anymore. This number out front actually tells us that our amplitude is equal to 2. So this graph is going to look the exact same, except instead of having an amplitude of 1, it's going to go all the way up to 2 and all the way down to -2. So it'll look a lot longer or a lot skinnier, however you want to think about it, and it looks like this. All right, thinking about this next example, there is no number in front of the sign x. So we know that this is an imaginary 1. So our sine function still has an amplitude of 1. We do, however, have this +1 at the end. Just like with a parabola, this +1 at the end means that we have a shift up. And in this case, it's shifted up 1. So if I were going to graph it, and this is just going to be a rough sketch, this graph goes to 1 and to -1. I need to take this entire thing, and now my axis is going to be shifted up 1. So it's no longer at 0. And so what's going to happen, and I'll graph it in blue, is that this graph is now starting 1 unit higher. Every single thing is 1 unit higher. So it looks the exact same, just shifted up. The next one, I have this -90. It's in brackets with my sign. So this is a shift left or right. We always need to remember that these shifts left and right are backwards. So this -90 actually means that it is a shift right by 90 degrees. So again, I'm going to graph my original. It's going to go to 1, to 0, to -1, and then back to 0. And it's going to happen in 360 degrees. And if I think about what's happening with my new graph, everything is shifted right 90 degrees. So this point is now going to be here. This point is now going to be here. Everything is moved over. So I'll do it in blue again. It's going to start here, go up, hit the middle, come back down, and then go back up. Exact same graph, just moved to the right. I know those were some really quick examples, and so I think that this chart is really going to be useful to help you determine which numbers represent what. It's going to be nice to look at this and just have a quick visual to see all of the transformations in one spot. So the first graph, y equals sine x, this is our original. Our OG, our original graph. We know that this original graph has an amplitude of 1. It has a period of 360 degrees. We know that the sinusoidal axis, and I'll just draw it down here, we know that it's at 0. It hasn't been shifted at all. And we know that there's no phase shift, okay? It's starting right at that 0, 0 point. If we look at 2 sine x, we graphed this. We know that this 2 is very important. This 2 represents an amplitude of 2. The period is still 360. That's not going to change in this course. It's always going to be 360. There was no shift up or down, so my sinusoidal axis has not changed, and there was no shift left or right. So this is going to be done as well, or none, sorry, as well. On top of this sinusoidal axis, I think I'm just going to write shift up or down, just so that you can look back and remember. And then here I'm going to write a shift right or left. That'll be a nice little reminder for you. All right, looking at this next one. The new information that I see is this +1 right here. This is after my sine x, so this is going to represent a shift up 1. So the number in front of my sine x is still a 1, which means my amplitude is 1. I said that the period is never going to change. Our whole graph has been shifted up 1. So what we used to have, our axes at 0, it's now being moved up 1. So our axis is now going to be at y equals 1. And there's no shift left or right, so this is none. Next one, we have this minus 90. Again, we've talked about this. There's a 1 in front, so our amplitude's still 1. Period is always 360. There's no shift up or down in this one, so there's no number at the end. So this is going to be my original y equals 0. But this time, we see this minus 90 in brackets, and so we know that this is 90 degrees to the right. It's always opposite. Minus 90 means to the right. Last one. I want you to give this one a try yourself. Pause the video, and then when we come back, we'll take it up. So looking at this first number, this 4, I do know that that's telling me that this now has an amplitude of 4. The next thing that I'm going to see is that I have this minus 90. So again, I do know that this means that it's going to be moving 90 degrees to the right. I told you that our period is always going to be 360. That's never going to change. And then the last thing that we see is this plus 1. This plus 1 is the shift up or down, and so my new sinusoidal axis is at positive 1. All right, so I've filled in this information. This is the last thing that we did in the chart, and we now have to graph it. So I filled in that our amplitude's 4, we have a sinusoidal axis at 1, our period is always going to be 360, and we are moving it 90 degrees to the right. Pause the video, take a minute, try and graph it, and then come back and unpause. All right, so I've put in this dotted line for my sinusoidal axes. I went 4 below and 4 above to see where my mins and maxes would be. I've started my first one at 90 degrees to the right, and then I did 180 past that for my middle, and then 180 past that for my final. So this would have a period of 360. And now it's going to be nice and easy for me to fill in my mins and my maxes and graph this beautiful function. Similar idea, take a minute, look at this equation, attempt to fill in my amplitude, sinusoidal axes, period, and phase shift. All right, so I've color-coded this for you. The number before the sign is a 3. This means that my amplitude is 3. I have a plus 2 at the end. This means that this entire graph is going to be shifted up 2, which means that my sinusoidal axis is at 2. The period's 360 always, every single question. And then because I see this plus 60, I know that this means that I have a phase shift of left 60 degrees. Take a minute, pause it, and I'm going to graph it. So I've drawn in my sinusoidal axes at 2. I know that my amplitude is going to be, so 3 above that, 3 below that. And then I put in my first point 60 degrees to the left. So that first point's on that sinusoidal axis. Now, I know that since my period is 360, I know that 90 degrees later it's going to reach a minimum, then back to my middle, then a minimum again. Sorry, this should have been maximum, then middle. So I've plotted all of those, and I can just now connect the dots. Knowing that my period is always 360, the fact that each of these sections is 90 degrees, so between my middle line and then my max, and then my middle line and then my min, and then my middle line again, is really beneficial for me. As long as I make my grid go up by 30 degrees every time, I can easily plot any kind of function that I'm ever given. All right, I want you to take a look at the assignment for this afternoon. I am going to be free this afternoon to answer some questions, probably period 4, end of period 3. I would love to have a meeting with the 5 of you if possible, and we can just kind of go through this again, just summarize everything and maybe do a couple of examples together.